Hey yo, what's up Mr. Davidson? This is Pana and Frederic, and today we're going to show you how to find limits using tables and graphs.
Here we have the notation that is read as the limit of f of x as x approaches a equals the number L. In the next notation is called the left-hand limit. This notation means that as x gets closer to a but remains at the same time less than a, the corresponding values of f of x get closer to L. The next notation is called right-hand limit. The notation means that as x gets closer to a but remains greater than a, the corresponding values of f of x get closer to L. This exercise, we have to find what the limit of 3x squared as x approaches to negative 9 equals to. Here we have that x approaches to negative 9. We use that negative 9 as a substitution in the equation 3x squared. Using that, we discover that is equal to 243. Recall that the notation limit of f of x as x approaches to a equals L means that as x gets closer to a but remains unequal to a, the corresponding values of f of x gets closer to L. Thus, the value of limit as x approaches to 0 of sine 5x divided by x as shown in the table is most likely approaching to 5, so that will be our answer. The graphic here is showing us that the limit of f of x as x approaches to minus 4 is like. The first step is to look our approximation of x approximating to minus 4. We reach the x-axis and go to minus 4. And then the same graphic shows us that it stops in minus 3 on the y-axis. So we have that it is equals to minus 3. So in the next question, f of minus 4 is equal to minus 3. Here in the table, the limit of f of x as x approaches to 0. In the first step, we have to look in the x-axis. We came to 0. Then we have to look where the graph stops us, and it stops us on minus 3. Then to find the value of f of 0, we have to examine the graph of x at x equals 0. At x equals 0, the open dot is not included in the graph of f. The graph of f at 0 is showing about the closed dot on the graph at x equals 0. Well, what is the y-coordinate of the closed dot at x equals 0? This is equal to the value of f of 0, that is, the number 1. Well, here we have the limit of 3 minus x squared as x approaches to minus 2. As shown previously, what we have to do is substitute the approximation of x, that is minus 2, in the equation 3 minus x squared. Our result will be minus 1.
For our final problem, we will be using this set of equations and this graph. And to start, if there is a single number that the values of fx approach as x approaches a from either side, then the limit is this single number. If there is no such single number, then the limit does not exist. So, as x gets closer to 4, but remains less or greater than 4, so x does not equal 4, then what number does the value of fx approach? And to solve this, we have to substitute our value in this equation since x does not equal 4. So, we substitute and it equals 5. Thus, the limit of fx as x approaches 4 equals 5. So these have been some basic problems. We hope that you have learned how to find limits using tables and graphs, and thank you for watching.